All right, now for my boys Edgar and Liam, we are going to do number 8 now, using, once again, mesh current method. And we are asked to find Ix and R1. So here we have an interesting problem. It wants us to find the value of a resistor, but they give us the voltage across it. So definitely doable. But we have to do mesh current method, and it specifically asks us not to simplify the circuit, which is kind of unfortunate, right? Because if we pay close attention to Ix here, we see that it is connected to open circuits, which means that Ix is equal to 0. And if Ix is equal to 0, then this dependent source is also equal to 0. And when you have current sources that supply 0 current, that's the same exact thing as an open circuit, which means this part of the circuit has no current either. So really what you're left with is the battery, the resistor, the current source, and then this, right? This is the circuit that you're left with, and then you would just do 2 mesh currents, and it's a super mesh. So just 2 equations and you're done. But unfortunately it says not to simplify, right? So I'm assuming that we're not allowed to do this. But I just wanted to show that thought process because that is a way to make your life a lot easier if you're able to do that. So with that in mind, we're just going to solve this the same way we do every other problem, right? We're going to define a mesh current for every single mesh, I1, I2, and I3. Now, we don't need a mesh current here because this is not a mesh, right? It's an open circuit. So it's not a closed loop, so we don't need a current there. So just wanted to point that out. Now we need our equation for I1, I2, and I3. Now one thing I failed to mention in the workshop that I'm now realizing is whenever you have a mesh that has a current source and it's not a super mesh, right? Like you see how this current source is in between 2 meshes, so it's a super mesh. But whenever you have a current source that's not a super mesh, you can simply let your equation be that mesh current, in this case I1, is just equal to that current source's value, 0.6 Ix. And that's it. That's all you need for that equation. You don't need a term for this variable or this variable. It's just I1 is equal to 0.6 Ix. So now, with that, we do our equation for I2 and I3 because it is a super mesh. So first we're going to write out our constraint equation, which is going to be 2 amps is equal to I3 minus I2, because this current is going with 2 amps and this current is going opposite of 2 amps. So that's our first equation. Our next equation is going to be our big loop around both meshes adjacent to the current source. So starting from the bottom left here, that's going to be negative 3 volts. And now we have to write this voltage value. We can't do I2 times R1 because that introduces another unknown. It makes our lives harder. So we can just write this voltage value because what we're doing is a KVL. And a KVL is just a sum of voltages. So we can just write minus 2 volts. And then we have plus 9I3 plus 7I3. And that completes our loop. So we'll set that equal to 0. Now we look to see for any dependent variables that are in our equations, and we do. We have one, that's Ix. But that's where you now use the fact that Ix is connected to an open circuit, so we can just simply say Ix is equal to 0. And then here's your 4 equations and your 4 unknowns. So from here, you just plug that into the calculator and solve. So once again, I'm going to punch this in real quick, make sure I get the right answers from these equations. If I do, I'll send this video over. And I almost forgot, right? The question's asking for R1 and Ix. So we have half of our answer, Ix, which is equal to 0. But now we need to find R1. And in order to do that, we're going to have to build an equation involving R1 somehow. And the best way to do that is just going to be to use Ohm's law, right? Because we know the voltage going across R1. We know the current going through R1. So we can just set up an Ohm's law equation, solve for R1, and we'll have our answer. But here's where you need to be careful. Because like we talked about yesterday, we have a current, I2, that is entering the negative terminal of the voltage value, which puts us in active sign convention, which still applies for mesh currents. Whenever you're in active sign convention, you have to use negative Ohm's law. So that's exactly what we're going to do. We're going to say V1 is equal to negative I2 times R1. And now we're just going to solve for R1. R1 is equal to negative V1 over negative I2. Oh, sorry. It's going to be just negative V1 over I2. And then we plug in our values for V1 and I2. So we know V1 is negative 2 volts. And we know I2 is negative 1.6875 amps. And that gets us 1.185 ohms. And that is our answer for R1. Which this one's not on the key. So you're just gonna have to take my word on it. But yeah, I'm feeling pretty good about this being the correct answer. So I'll get this video over.